Let's look at this example. This example is very similar to a lot of the problems in your tutorial homework. We have a single can, a pop can, sitting on a table. If I draw a free body diagram for that, I have the weight down, earth on the can. There's no magnets. We're getting to them. Just be patient. So what touches the can? Well, the table. Does it push or does it pull? It pushes. Whenever one thing pushes on another, there will always be a normal force. There may also be a friction force, but I don't need one if that's a level table. Now, those two forces are equal and opposite by what law? By second law. Second law with zero acceleration. Now, in your tutorial homework, on the first page and part of the second page, Lillian McDermott is trying her darndest to get you to see that those are not third law companions. And in this example, we can show that's true by putting that can and that table in an elevator with acceleration up. Now, before we go further, is that elevator moving up or moving down? Is it going up to the 10th floor or going down to the lobby?
Going nowhere.
Do we know? No. If it's going up, what is it doing? Speeding up. If it's going down, what is it doing? Slowing down. And both of those feel exactly the same. If you don't have windows in your elevator and you don't have any glowing buttons, you don't know which one you're doing. Okay? Now, this diagram has to scream that acceleration. So what has to change in my diagram? Does this one change? No. The earth is pulling on that can regardless. It doesn't care what the can is doing today. The only way you can change that force, people, believe me, is diet or exercise. If there were something else, I would have done it. Okay? Diet or exercise. So in order to make this diagram scream up, the normal force has to get greater. And now we see that these could not be the equal and opposite third law companions because they're not equal. Now, what is the companion force to that normal force? Well, what flavor would it be? Normal. And instead of table on the can, it would be can on the table, like that. What free body diagram would I find that on?
The table.
Yes, this is a force by the can on the table. And that means it's on the free body diagram of the table. And I would put one tick mark on each to show that they're part of the same interaction. Now what about this gravitational force? Does it have a third law companion?
Yeah.
All forces have third law companions. This is the earth pulling on the can. If I look at a free body diagram for the earth, there will be a bazillion different forces, but one of them will be a gravitational force of the can pulling up on the earth. And I would put two tick marks there. Now, if you're ever comparing forces on the same free body diagram, on the same dot, you use Newton's second law, and you qualify it. I would say that normal force is bigger than the weight by Newton's second law with acceleration up. But whenever you invoke Newton's third law, you just say they're equal by third law, full stop. You don't care whether it's accelerating, not accelerating, Tuesday, Friday. If they're equal by third law, they are always equal by third law. And you can recognize they're equal if they're the same flavor with the same indices reversed. Now, 23 years ago, I came to this campus and joined the faculty here. I have a different sort of a job than most of the professors here. I teach a lot. I don't do as much research. I write textbooks. Now, that first year, a graduate student came and said, a member of my thesis committee has bailed out. He left town, and I'm supposed to have my graduate PhD thesis defense on Friday. Could you fill in? I said, sure. So I show up, and at a graduate level PhD thesis defense in our department, 5 professors from physics and 1 professor from another department listen to a presentation for 45 minutes, and then grill the student for as long as they want. They can ask any question about physics. So this student, we'll call him Bill, that's not his real name. This student was brilliant, and he gave a wonderful presentation. He just had everything just nailed down. And then we started asking him questions. And after 2 hours, it started to become apparent to the others in the room that this new guy, Greg Francis, had not yet asked a single question. And finally, it became so obvious that the chair of the committee said, Professor Francis, would you like to ask a question? And I said, sure. Bill, you got a can on the table there. Would you draw me a free body diagram for it? And the other professors were kind of concerned that they had hired the wrong guy. And Bill was just disgusted. This is his thesis defense. He just goes to the board with a look of scorn on his face, and he says, well, there's weight down and there's a normal force. I said, okay, Bill. Newton says for every force there's an equal and opposite reaction force. What's the third law companion force for that normal force? Bill went to the board and he said, well, a force that's equal and opposite to that is that. And suddenly the other professors in the room knew where I was going. And I said, well, Bill, why don't you just lean over and push down on that can? What happens to your free body diagram? He says, well, I have a push, and that gets bigger. Wait a minute, Bill. You said that normal force was a companion force to the weight. They're not equally anymore. He looked all concerned. He got really, really nervous. And he said, but that force is equal and opposite to those two. I said, oh. So every force, there's an equal and opposite group of forces. And then he really got nervous. And I said, Bill. I said, Bill, don't push down on the can anymore. Let's just put the whole thing in an elevator with acceleration up. What does the diagram look like now? He said, it looks like that. There's only two forces, and they're not equal and opposite. And he looked concerned, he looked worried, and then suddenly he burst out into a smile. He said, oh, Newton's third law doesn't apply when something's accelerating. And the room turned to ice. I leaned forward and I said, Bill, your dog will die. Your children will move away from home. But Newton's third law will always apply every single time. And that's my message for you. Okay? Have a good weekend, people. We'll see you on Wednesday.